In this final topic, we're going to be looking at more compound interest problems. So to start off, let's just try these BEDMAS questions. So when dealing with fractions like this, kind of think of doing everything in the numerator first and everything in the denominator first, so do them separately. And then your final step will be to divide the numerator by the denominator. So how I would solve this first one, I'll move it off to the side here, is I would solve everything in the numerator first. Well, there's nothing in the numerator to do because there's only a 500, so that'll stay the same. And then moving on to the denominator, I would solve everything there first. So I would follow BEDMAS. So I would start with everything in the brackets. I would do 1 plus 0.1, which would be 1.1, and then to the power of 4. And then if I continue with BEDMAS, I would do 1.1 to the power of 4 in the denominator, which would give me 1.4641. And then my final step is to divide those two numbers. So I would do 500 divided by 1.4641, and you should get 341.51. So that would be the answer for that one. In the next one, you're going to do the exact same steps, and you should get 907.03. So please try doing this and making sure you know how to plug that into your calculator. But now let's move on to the compound interest problems. May is a cashier at a wallpaper store in Calgary. She invests in a savings account each month. The interest rate is 1.3% per year, compounded annually. So we're back to the word annual. And after 2 years, one of May's monthly investments is worth $97.49. So how much did she invest that month? So this time they actually gave us the final amount. So where it says after 2 years, one of May's monthly investments is worth $97.49, that is the amount, the A. So what we want to do now is find how much she invested, aka the principal or the initial amount that she invested. So we're looking for the P. So we're going to take the formula we have and we're going to plug in the information that we know. So we know that A is $97.49. We don't know what P is, but we know that interest rate, that lowercase I, is 0.013 because that 1.3% per year interest rate. And then the amount of times it's compounded, well, it's compounded annually, so once a year. And we know it goes for 2 years. So we know in total, we're going to compound it 2 times, twice. So now let's solve how much she invested that month. So let's solve for P. So what we're going to do is we're going to isolate P and get it all by itself. So in order to do that, we kind of need to tidy up everything beside it so we can eventually cancel that out. So this side, there's nothing really to tidy up, so I'm going to keep that the same, $97.49. But let's tidy up this side. So do 1 plus 0.013 in the brackets, which would be 1.013, and then that to the power of 2. So if you do that, you should get 1.026. So now it's really easy for us to isolate P and get it by itself. All we need to do is divide both sides of the equal sign by 1.026 to cancel it out. So we're going to do that on both sides of the equal sign. So that's what they're showing us here in this next step. We're going to have $97.49 divided by 1.026. And we're dividing because over in this step, it is multiplying with the P. So the opposite of multiplying is divide, and that's how it cancels it out. So then 97.49 divided by 1.026 is equal to $95.003. So not even 3 cents. So we'll just say May invested $95 that month. So that is her initial amount. Moving on to the next example. Daisy wants to start saving for a party for her business in 5 years. The interest rate for Daisy's investment is 3.2% per year. The interest is compounded annually. How much does Daisy need to invest now to have $4,000 after 5 years. So they want us to solve for the principal amount again. They want to know how much she needs to invest in order to get the amount A of $4,000. So we have A is 4,000. Now let's do the interest rate per compounding period. So that's I, or a lowercase r, I like to look at it as. So that is 3.2%, or in other words, 0.032 when we plug it in our formula. And then let's look at the amount of compounding periods. So again, it's compounded annually. So that's once a year, which makes things easy for us. Once a year. And we know it's going for 5 years. So the amount of times they're going to collect that interest in the 5 years is 5 times, because once per year. So now how much money, the principal or the initial amount, does Daisy need to invest now? So we're going to take our formula and plug in what we have. So we have that A is $4,000. We don't know P, but we know the interest rate is 0.032, and we know the N is 5. So now we need to get P all by itself once again. So let's simplify all of this here. So in your calculator, you're going to add up everything in the brackets. So 0.032. So you're going to have 1.032 and then to the power of 5. So you're going to plug that in your calculator and you should get 1.170. And then that 4,000 is still on the other side. So now we need to isolate P and get it all by itself. So we're going to divide both sides by 1.70 because that will cancel it out. 1.170. So that cancels us out there, and we're going to do the same thing to the other side of the equal sign to keep it balanced. So then in this next fill in the blank, we got 4,000 divided by 1.170. And if we divide those two numbers, you should get that the principal amount is $3,417.13. So Daisy needs to invest $3,417.13. Now, in the next part of this topic, they're introducing what is called the Rule of 72. And this is a really easy formula for us to use to estimate how long it will take for an investment to double. So estimate how long it'll take for an investment to double. So what the Rule of 72 is the years for it to double is equal to 72 divided by the annual interest rate as a percent. So for this formula, you're going to be using the rate as a percent. This is the only one where we don't have to switch it to a decimal. So for example 2, James runs his own business as a locksmith. He is responsible for saving for his retirement. He invests in his RSPs every year. 1 year, he invested $3,000 at 3.6% per year compounded annually. How long will it take for James' money to double? So whenever you see a question asking how long it'll take to double the money, think to use the Rule of 72 formula. So let's see how this works. So the interest rate as a percent is 3.6%. And remember, for this formula, we don't have to convert that to a decimal. We can keep it as 3.6%. So the years to double, all we have to do is do 72 divided by 3.6. And if you plug that in your calculator, you're going to get 20 years. And that's all there is to it. It will take about 20 years for James' money to double. Now, remember, this formula, the Rule of 72, is just an estimate. So we can actually check to see if this estimate is reasonable or if it's close. So let's use the interest formula we have and calculate. So the principal amount that we are using is $3,000. That's how much he invested. And then the rate is 3.6%. So for this formula, we have to change that to a decimal. And all we're doing in this one is we're checking to see if it will double in 20 years. So I'm going to take that 20 and I'm going to put that over here. So 20 years. So 20 is the N. So then if we plug this in our calculator, remember to do everything in the brackets first. So 1 plus 0.036. Then you're going to put that to the power of 20 and times it by 3,000. And if you do that all correctly, you should get $6,085 $3,000.78. So therefore, the amount is about double the $3,000. So the estimate is reasonable. So all we were doing in this one is trying out that rule of 72 and then seeing if it actually works, which it does. That's about double what 3,000 is. So 3,000 times 2 would be 6,000, which is pretty close to what we got with that formula.